will have 0.25 moles of oxygen. Well, they probably don't want number of moles. They gave us a value in mass. So we have to convert this answer to mass. How do we do that? We say mass is equal to number of moles times the relative atomic or molecular mass. How many moles? 0.25. What is the molecular mass of oxygen? It is 2 times 16, so it's 32. So our answer is 0.25 of 32 gives me 8 grams. 8 grams. So 8 grams of oxygen will react with 12 grams of magnesium, and it will form magnesium oxide. All right. Now, here in the second question, they say what mass of magnesium oxide will be formed when the 12 grams of oxygen reacts? Well, we use the same equation. We now know that 2 moles of magnesium will react with 1 mole of oxygen, and it will form 2 moles of magnesium oxide there from that equation. So we know if we have 12 grams of magnesium, we've just worked it out over here, then we will have number of moles is 12 over 24 is equal to 0.5 moles. Okay, you don't have to do that again. I've just done it to show you. We've got that from there. Now they want to know how much magnesium oxide will we get if we have excess oxygen, more than enough of oxygen. It's not a limiting factor. So what do? We're going to look at the ratio of magnesium to magnesium oxide. Now the ratio is 2 to 2. So if I have 0.5 moles, how many moles will I get over there? 0.5 divided by 2 times 2 will be 0.5 moles. Okay? We don't want the number of moles, we want mass. Number of moles times, now the formula mass for magnesium. Magnesium is 24 and oxygen is 16. So 24 plus 16 is 40. So 0.5 times 40 will equal a mass of 20 grams. So 12 grams of magnesium will react with excess oxygen, and it will form 20 grams of magnesium oxide. Okay. Here we've got a question with the gases. So during the Haber process, nitrogen reacts with hydrogen to form ammonia. Can you see the balancing ratio is 1 to 3 to 2. So what volume of hydrogen, there, we're looking for that volume, is needed to react with 96 decimeters cubed? Now, we can go and work out number of moles over here. From that, we can work out number of moles is volume over 24, which would give me 96 divided by 24 is 4 moles. Okay, the next step, use the ratio. The ratio is 1 to 3. So we have got 1 to 3. I have got 4 to how much? So 4 divided by 1 times 3, it will give me 12 moles. From that we can go and work out the volume. Now the volume is going to be number of moles is volume over 24. So if we are looking for volume, it is going to be number of moles times 24. So we have 12 moles times 24. And that will give me the volume 12 times 24. sorry, 288 cubic decimeters. So we would, no, I have a mistake. How much? Oh, how much hydrogen? The ratio is 1 to 3, so that is right. Okay, my answer is correct. All right. What volume of ammonia will be formed? Well, we have the ratio. If we started off with 4 moles of nitrogen, how many moles of ammonia would we get? The ratio is 1 to 2. So in the ratio 1 to 2, I now have 4. So I will have 8 moles over there, and the volume of 8 moles, volume is going to be 8 times 24 is equal to 8 times 24 is 196 decimeters cubed. And now, what mass of hydrogen will form when 8.5 grams of ammonia? All right, I'm just going to rewrite the equation. We have nitrogen plus hydrogen will give me ammonia. All right, we have to balance it. Well, we have 2 nitrogens there, so 2 there, but now we have 6 hydrogens, so 3 there. So now they say, what mass of hydrogen? We want to know what mass will form 8.5 grams of ammonia. So now the steps stay the same. From what they've given you there, work out the number of moles. So they've given us a mass, so we use the formula that contains mass. So it will be 8.5 divided by, what is the molecular mass of ammonia? Nitrogen is 14, hydrogen is 1, there's 3 of them, so it is 17. So the number of moles is 0.5 moles. What do they want? So the next step, now, what do? We use the ratio that they've got from the balancing. So the ratio is 3 to 2. But we don't have 2, we have 0.5. All right? So how much of that one? So 0.5 divided by 2 times 3. So 0.5 divided by 2 times 3 will give me 0.75 moles of hydrogen. They don't want number of moles, they want mass. So mass, number of moles times the molecular mass for hydrogen is 2. No, 1 times 2. So the number of moles, 0.75 times 2 will give me 0.75, oh goodness me, 0.75 grams of hydrogen will be used. Another one. Here we have a solution and a solid. They give us the equation. Magnesium reacts with hydrochloric acid and it forms magnesium chloride. So the first step is to balance your equation. Probably they might give it to you. Sometimes they don't. So 1 magnesium, that seems fine. 1 hydrogen, oh, here's an error in my equation. I must have hydrogen there as well. So 1 hydrogen, 2. So I will need 2 over there. There I have 2 chlorines, and there I have 2 chlorines. So now it is balanced. Now they say, calculate the volume of hydrochloric acid. They say this hydrochloric acid has a concentration of 2 moles per decimeter cubed. Okay? And they want to know what volume is required to react completely with 12 grams of magnesium. So First step, from what they've given you, work out the number of moles. Now we have mass, it's 12. The relative atomic mass of magnesium is 24, so I have 0.5 moles. All right? The second step, use the ratio. Here we have 1 to 2. So the ratio is 1 to 2. So I have got 0.5 divided by 1 times 2 is going to give me 1 mole. All right? But we don't want to know how many moles. We want to know what? Volume. Which formula contains volume of a liquid? Well, number of moles is concentration times volume. So volume is number of moles divided by concentration. Do we have the number of moles? Yes, 1. What concentration was given? 2 moles per cubic decimeter. So what volume would we use? 0.5 decimeters cubed. Okay. Let's have a look at another one. Okay. Now, those calculations that we've done here all use the formula that connects the number of moles. Now, except for these calculations, we can get another type of calculation. Here it says, calculate the empirical or simplest formula and molecular formula. Okay, now, they say an unknown compound contains 2.4 grams of magnesium and 1.6 grams of oxygen. So we must figure out what is the formula of this compound from the stuff that they've given us there. So when they do this, when we need to calculate empirical or simplest formula, we take the mass that they gave us and we divide it by the relative atomic mass. So we would say for magnesium, we have got 2.4 divided by 24. And here we have oxygen. For oxygen, we have 1.6 grams, and oxygen, the relative atomic mass is 16. So over here, my answer is 2.4 divided by 24 is 0.1, and over here, my answer is also 0.1. So this means that this substance, this unknown compound, has the formula magnesium 0.1 and oxygen 0.1. Now, can we have half numbers there? We need to get them as whole numbers, all right? So what we're going to do is we're going to look at these values and we choose the smallest one. Now, in this case, they are both the same. So we divide 0.1 by 0.1, and over here 0.1 by 0.1. And we will get 1. Okay, so my formula is magnesium oxide, 1 magnesium and 1 oxygen. We don't show the 1. That would be the simplest empirical formula. All right, the empirical formula is the simplest formula. Now, sometimes we find that the molecular formula differs from the simplest formula. Remember, when we write formula, we have to have the numbers over here in the smallest ratio. For example, if I have carbon dioxide, carbon has 4 bonding places, oxygen 2, so I will need 2 carbons and 4 oxygens, but carbon dioxide is not written C2O4, it is written CO2 because I divide both by 2. Okay, so the next question that they tell us here, an unknown compound contains 10 grams of calcium, 3 grams of carbon and 12 grams of oxygen. Determine the empirical formula. So when we need to get the empirical or simplest formula, we take the mass of that element 10 grams of calcium, and we divide it by the relative atomic mass. Calcium has a relative atomic mass of 40. Carbon, we've got 3 grams. The relative atomic mass of carbon is 12. And oxygen, we've got 12 grams. The relative atomic mass is 16. So now we go and work out what the answers are. That one is 0.25. 3 over 12 is also 0.25. And 12 over 16 is 0.75. Okay, so it seems as if the ratio is calcium 0.25, carbon 0.25, oxygen 0.75, but we want whole numbers. So what's the trick? How do we get whole numbers? We divide each one of them by the smallest number. What is the smallest number? 0.25. So we say 0.25 divided by 0.25 is equal to 1. But I must do that to the others as well. So 0.25 divided by 0.25 equals 1. And here I have 0.75 divided by 0.25. I get 3, and now we've got something that is recognizable. What is the ratio? 1 to 1 to 3. So what is the formula of my compound? I have calcium and carbon and oxygen. I have 1 calcium, I don't show the 1. I have 1 carbon, I don't write a 1. And I have 3 oxygen. So what do I have? Calcium carbonate. Okay? Now they say calculate the molecular formula. Remember, these that we've done is the empirical, the simplest formula. Now the molecular formula can be multiples of the simplest formula. So here that we explain it. If I look at methane, the simplest formula for methane is 1 carbon and 4 hydrogens. And the molecular formula also happens to be CH4. But ethane has got a molecular formula of 2 carbons and 6 hydrogens. Now that's not in the simplest form. All right. In its simplest form, it is CH3. So that would be the molecular formula, and that one would be the empirical formula. All right, the simplest formula. So they say propene has a molecular mass of 42. Now, propene is one of the organic compounds with 3 carbons and a double bond. Okay? So propene has got hydrogens on it. There, 1, 2, 3, 4, 1, 2, 3, hydrogen and hydrogen. So the formula for propene, okay, is going to be C3H6. See, let's see if we can work it out from what they give us. They say determine the molecular formula. Remember, I know this from the organic chemistry. Let's see if we can get that answer. So, they say the whole thing has a molecular mass of 42, of which 36 grams is carbon and 6 grams is hydrogen. So let's work out the empirical formula. For carbon, it's going to be 36 over 12, and hydrogen, I will have 6 over 1. So over here, I get 3, and over here, I get 6. So from what I've worked out over here, my molecular formula is going to be C3H6. And now in the next part, they say determine the empirical formula. What's the empirical formula? The simplest formula. So we have to simplify that. How do we simplify it? If I have C3H6, I must simplify those values. So 3 goes once, 3 goes twice. So the empirical formula is going to be CH2. All right. Now, They give us not masses, but a percentage. But remember, percentage means it is a part out of 100. So it's as if they gave us 100 grams and the percentage is the mass out of the 100 grams. So find the empirical formula of an organic acid that has a percentage composition by mass, 40% carbon, 6.6 hydrogen, oxygen is 53.4. So carbon is going to be 40 over 12. Hydrogen is 6.6 over 1. And oxygen is 53.4 over 16. So we have to go and work them out. 40 divided by 12 equals 3.33. 6.6 divided by that is going to be 6.6. And 53.4 divided by 16 also gives me 3.33. Now, we don't have a whole number. What do we do to get a whole number? We divide all of them by the smallest. What's the smallest value? 3.3. So 3.33 divided by 3.33, 6.6 divided by 3.33, and 3.33 divided by 3.33. Here we will get 1, here we will get 2, and there we will get 1. So what is the ratio of these elements to each other? It is going to be C1, H, 2, O. There we go. There we have the formula. Okay, now sometimes they ask us to work out something known as the percentage composition. Now, percentage composition, if I say to you, your class consists of 40 learners, of which 27 is boys, and 13 of them are girls. What is the percentage composition of boys and girls? Well, then we would go and say the percentage composition of girls would be 13 out of 40 times 100 over 1, the part out of the whole. And the boys would be 27 out of 40 times 100 over 1, and that would give me the percentage of boys and girls. Now, we're not busy with boys and girls. Here we have got elements in a compound. So they want to know what is the percentage of calcium in calcium nitrate, nitrogen's percentage, and oxygen's percentage. So what do? Well, we work out the molecular mass for that compound. Calcium is 40. Now, nitrate consists of nitrogen, which is 14, and there are 3 oxygens. So it's 3 times 16, but we will have 2 of the whole nitrate thing. So we get a total mass of 164. So in that substance, this is the whole, and these are parts, okay, of the whole. So what percentage would be calcium? Well, the 40 grams out of the 146 grams would be the calcium percentage. So 40 divided by 146 gives me 24%. What percentage is nitrogen? Well, we have got how many nitrogen atoms? 2. So 2 times 14 is 28. So we have 28 over the 146 as a percentage. And lastly, the oxygen is 3 times 16, but we have 2 of them. All right, so don't be caught out by that. There are actually 6 oxygens in that compound, so it's actually 6 times 16, which would give me 96. The 96 is equal to 6 times 16, because we have 6 oxygen atoms. And that gives me a mass of 58.5%. So the percentage composition is I have got 24.4% calcium, 17.1% nitrogen, and 58.5% oxygen. They can also say, what percentage would we get, the percentage yield? They say magnesium carbonate is decomposed to form magnesium oxide. Now the equation would be, I have magnesium carbonate, and they're going to heat it, and I'm going to get magnesium oxide and carbon dioxide. Okay, so now they say to us, we get 15 grams of magnesium oxide. They say, we actually expected 19 gram. So what is the percentage yield? Well, we thought we would get 19. We only got 15. So the percentage yield is 15 over 19 times 100 over 1. It would give us a 79% yield. Sometimes they can ask us percentage purity. They say we have 12 grams of a substance. And we found that when we analyzed it, it only contained 11.57 grams of the active stuff we were looking for. In other words, there was a little bit of fillers added or impurities in it. So what is the percentage purity? Well, it is the 11.57 divided by the 12 as a percentage, which would give me 96.4%. Okay, I think those are the examples that I have. I have one or so typical exam type questions. I just don't have them typed up, but I will try and write them out. They say, sodium carbonate reacts with sulfuric acid to form sodium sulfate, water, and carbon dioxide. So sodium carbonate reacts with sulfuric acid, and it's going to form sodium sulfate in a 2SO4 plus water plus carbon dioxide. There is our equation. We have to balance it. 2 sodiums. I wonder if I can move the... Oh, no. Undo. I want to move this thing over there, make it slightly smaller. Okay. We have got 2 sodiums. 2 sodiums. We have 1 carbon, 1 carbon. We have 1, 2, 3 oxygens, and we have 1, 2, 3, 4 over there. So there we have 1, 2, 3, 4, and here we have 1, 2, 3. So the oxygens seem to be okay. We have 2 hydrogens. There are 2 hydrogens. We have 1 sulfur, 1 sulfur. Our equation is balanced. So this is going to be easy because the ratio is 1 to 1 to 1 to 1 to 1. Okay. So they tell us we have got 53 grams of sodium carbonate. And it reacts with excess, in other words, more than enough sulfuric acid. They want us to calculate the number of moles of sodium carbonate in 53 grams. So, number of moles is mass over the molecular mass. So we have 23 times 2 plus 12 plus 3 times 16. There we have the molecular mass. So we have 53 over, let's just work that one out, 46 plus 12 plus 16 is equal to 106. So the number of moles is 0.5 moles. Now the next question that they ask us